Hiya. Uh, that's the rotor. That's a pedal bike brake hub because it's got a small gap in the middle. If it was a motorbike, it'd be a much larger gap to fit around the wheel. But yeah, there's 6 neodymium magnets I've had sitting on my wall for ages, so I thought I'd make use of them by making them into a rotor. Obviously using that as a backing plate because yeah, that isn't perspective. That's the size of the thing. Yeah, and that's the small one. This wire was intentionally going to be for another project, but as you can see, the wire leaves a gap in the middle, and this is only 3 layers. I need 5 layers, so I've got to order more wire at the right size. This is 1.0619 AWG, even though on the website it said it was 18 AWG, which I need 18 AWG at 0.99 of a mil, and this one's +0.6 of a mil, so it's too big anyway. But yeah, it's going to be part of a wind turbine that I'm just going to build. This is a coil winding jib, as it was. It's kind of all improvised. I might actually, I'm thinking about using this metal pole here, which is from a drive-on lawnmower, but as from my old job, I was going to move this down to here, have that attached to that hub down here, which will be up here, giving me a drive shaft, or indeed a shaft that's strong enough, could be in solid metal, to support an axial flux wind turbine. Sorry about this shaking the camera. Yeah, but for an axial flux wind turbine. Where are you? Room's an absolute mess. This is the other spools. There's 2 of them. Now these are 1,000 gram. That's 500 gram. And this one was 1,000 gram spool. There you are. Pretty nice from, what's that? Brockets.co.uk on eBay. Basically, it's pretty much the biggest selling one on eBay. It's all enamelled wire. Fairly good size. Well, I'm going to use most of this. Well, maybe not all of it actually. I might even just use only the 500 gram as the coils. Due to it being, due to me only having 6 magnets, which happen to fit on the circumference of this. You see that brake mark, the blacky line right around the middle here? Well, the magnets just happen to be the right spacings. And this isn't mine, I bought this off eBay, but it's got these black marks on. But that black marks actually happen to be the spacings to fit 6 magnets, or 12, because 1 magnet will fit in between each of these. And the pizza guy's here, so I'm going to cut the video short. Everyone always gets confused by our gates, but yeah, that just happens to fit that. So yeah, just showing what I'm doing. I know. As for this, I put on an extra band because it kept on coming off. It seems to hold it in place. If I turn it this way, everything stays in place, but if I turn it the other way, it all comes off. But as you can see, from 1 rotation, I get many on the front one. That's from a half a rotation to a full one. It worked quite nicely. I haven't got something strong enough to actually start this up, you see. Obviously I can't just go like that and it goes and takes off like a jet engine, of course not. I need airflow to start it initially. Yep, I know. To get this going. I tried putting a drill on here and cranking it, which it went pretty fast. But obviously the drill itself is a set speed, even though when I pulled the trigger at max, the original elastic bands broke. But it would, if the drill stopped, it stops. I couldn't pull it off to just see if it keeps going. I was thinking about putting neodymium magnets on here and actually making a pulse motor onto this to see if I can get this up to speed. Obviously, if it runs faster due to the airflow thingamabob happening, the pulse motor itself will be maxed out, and then it will be running faster. Oh yeah, it's just an idea, just to show that one. I think it's cool. And that is a vacuum hub, not a vacuum hub, a vacuum motor hub. Sorry, to get the gear ratios. Okay, so just showing projects. Okay then, my food's here. See you later. So it's been a fair bit of time, and my hands would not stop going into cramp. But this is the first coil for the wind turbine, the Vawt or vertical axis wind turbine. This tube here will hopefully pull out the middle. I've already just put a layer of glue across here to hold it all together and tacked in a few loose ones. But other than that, that's the first coil. This is the coil winding jib. Makeshift. This is a rotor off of something else, but it just happens to be a decent size. I can use it as a crank. The black mark there is roughly how far out my coil needs to be. Just a bearing there, cable tied and super glued onto a back box of something else, another project. That's the coil of wire in comparison to my hands. Nice and big. But yeah, I gotta make another 14 to make 3-phase. Since I've got 6 magnets, 6 times 3 is 18, not 14. 18, yeah. My cat likes to really go on my lap. She's just sitting there, staring at it. Yeah. You know I'm talking about it, don't you? Do you want to go on my lap? No. Anyway, yeah, so that's the stator. 6 magnets, 6 times 3 is 18, I think. But yeah, gotta make another, oh god, I gotta make another 17 of these. Oh, it's absolutely killed my hand. And it was put on like so, and I wrapped it to get it off, because I did put layers of glue throughout the whole wrapping of it, which I used rather sort of quite cleverly actually, because it's quite a small gap. I put a drop of glue as it was onto this cable tie on the end of that, and then just got the little drop and just fed it around the outside. So just went around it and tacked it in place. But I used some strong string to run around here once I loosened it off to break off any glue on the outside, and I've got to do that on on here in between that gap. Although there is no gap, I'm going to have to make one. I knew I shouldn't have stuck that core in. I'm a bloody idiot. Yeah, I thought earlier, oh brilliant job, I'll stick that in the middle. But ideally, I could have just popped it out, and then it would have just popped right out with both sides exposed and support in the middle. But no, damn it. Okay, yeah, just showing that. Right, have a nice night, and see you later. And that's what the finished one looks like. This is the first one still. I managed to prise it off. It had some loose ones here and there, so I had to tack them in. And the middle was playing up a bit because I didn't put enough at the start, and it just kept on coming loose. So I glued it back in place. That's it. It's 5 deep by 15 turns. I think it should have been 14 turns. But then again, I measured it on that. But yeah, due to the wire being 1.06 millimeters thick, it obviously doesn't add up to 15 turns for 1.5 centimeters. It adds up to just more. so I had to put 14 turns to fit the spacings around, which actually reminds me, I did not check it. Let's have a look. Let's put the wire that way because it fits. Oh, look at that. It's perfectly around it. Slight hick on the one side, but not too bad at all. So that's where that one's going to go. There's going to be another one here. Like I said, that's why I had to have it quite close because as you can see, they're going to be right next to each other. So that's going to have to go there as flat as possible. Might even have to really. I did go by the measurements. I didn't actually count how many there was, so I might have to take a wrap off one, or even take a wrap off the one off the outside of this to reduce its width. Whether that would be, I mean, I'd have to take off 5 layers. Screw it, I'll just squeeze it all in as best I can. Yeah, doing 3-phase, obviously the shear size of this one means that I was gonna, or still am gonna, this is my knee, so that's the flat surface, obviously it goes on like that, but what I'm gonna do is just simply stack them like that. So there'll be another one where my finger is at the back there. There are 5mm each, so each one's stacked across at that angle, sort of. Obviously not as steep, just off. Stacked on top of each other, going all the way around. Means it'll only take up about a space, so 5mm, plus another quarter, no distance quarter, 2.5. So take up another that amount. So the overall stack of it at the angle, where the lowest and highest point will be about that. I mean, that ain't too bad. From these, anyway. I can actually use the back of this rotor as well, due to like the sheer strength of these magnets and the open space of these coils. I can actually pick up individual fields all the way around, so I could actually dual side the coil. That's one thing I've never got about, when people make wind turbines is, why don't they just have one rotor and coil on one side, coil on another, and then just thin plates, which is what I'm going to do with that computer backing board there, that compute door. But yeah, you have one rotor, magnet coils either side of that. Ooh, let's use the slats in the wallpaper. So this is a coil. I mean, that's the rotor. You'd have your coil here, and your coil there, and just behind the coils themselves will be just thin slats of pieces of metal that draw the magnetic flux out, and obviously across the coils. So that means instead of spinning a rotor that's got 2 lots of magnets on, that weighs a lot, you'll spin one rotor that, it's just one set of magnets with 2 lots of coils on, and the magnetic flux will be drawn to the outside. It's one thing I've never got about when wind turbines are made. It plus it costs a lot, a big chunk of steel like that. I mean, what was that? £2, £3. Or again, you don't even have to use metal. You can use resin or wood or plastic. Again, lighter, more expendable, mass-produced materials rather than, example, precision-cut piece of steel. Again, lighter equals more sensitive to the wind, more sensitive to winds equals more power, more efficient. Just an idea, or just one of them things. Okay, that's enough for today. Literally, one coil a day is going to be a long time, but now I'm going to do 2 or 3 in a day. For now. Okay then, have a good night. See you later.